Yeah, in fact, they're found all over the planet. So we're seeing them in the Arctic and not just Florida waters, but really all over. It's really quite remarkable. And the problems are severalfold. First of all, I'm talking about the small plastics. Is that correct? The microplastics? So there are a lot of organisms in the ocean that are filter feeders. So they take the water and filter it. And normally there are things that are good to eat in the water that they filter out. But of course, if there are microplastics, they get filtered out, and the organisms get full because they think they're eating something, and in fact, they're not full, and that has obvious consequences because they think they're eating, but they're not.
And what about on a smaller level, on a chemical level, when organisms have plastics in their bodies, and those plastics are giving off chemicals?
Right, right. So it's not just the fact that they're plastic, but it's really interesting. There's a whole suite of chemicals, many of which are toxic, like PCBs, and they're concentrated 100,000 times to 1,000,000 times higher than the background water levels. So really high concentrations of toxins on those plastics.
How about effects on human health?
Well, to be honest, we don't know yet the effect on humans. We're looking at it. I love oysters. I like to eat oysters, and oysters are filter feeders. So we'll see if oyster eaters get more cancer. But in fact, in general, there's a lot of things around human health that we don't know. Why are we getting so many cancers? Why do we get these illnesses? Why do we get these diseases? And those unknowns are still out there.
Well, you mentioned PCBs. What about for someone who doesn't know much about the chemistry of plastics, or what other things could there be in plastics that might be causing these problems?
Right. Well, there's a whole suite of chemicals, and I don't want to teach a first-year level in organic chemistry here, but there are lots of things that physically stick to the plastic. So the plastic is kind of sticky. The way a balloon might stick to a wall, these toxins might stick to the plastic. The plastic is a really interesting surface. And there are a lot of different bacteria on them and a lot of different chemicals, many of which are harmful to the organism that's eating them. And then, of course, if we eat the organism or fish eat it, then it goes up the food chain.
So it sounds like we established that there might be health effects of having plastics in the environment,
right.
But what are the solutions?
So, yeah, it's good to point out these plastics get there because we're throwing them out, we're dropping them, we're not recycling them. So even well-intentioned folks, we don't recycle the plastic very much. Plastic recycling is very difficult, and the industry is losing billions of dollars every year by throwing out these really valuable products when we could actually have a closed loop. So we all recycle paper, most of us recycle aluminum cans. If we start to recycle these plastics better, then that might be a solution. But right now, plastic recycling is really in its infancy.
Those are my questions. Is there anything else about plastics in the environment that our listeners should know about?
Yeah, that the marine science community is just beginning to get a handle on this. I mean, it's very early on in this, and there are so many plastics in the ocean, the water. It's really quite astounding. If we don't stop this, there's going to be as much plastic by weight in the ocean as there are fish. And so it's really pretty a great concern, and we need to do something about it. We need to stop wearing plastic clothes and or at least reuse those plastic clothes. Clearly plastic water bottles, that sort of thing, but the whole industry is revolving around single-use plastics. We need to get off of that.
Great, thanks so much for your time.
You bet.